Hello, everyone. We are again with another episode of Tech Thinkers, and I hope in this evening of winter, you will all be enjoying your evening snacks, coffee, tea, and we will try over next around 1 hour. We'll try to make it um, an interesting discussion where you will enjoy your coffee and tea. So as I have repeatedly been saying that tech thinkers is all about bringing people who who really mean to their industry, to their topic, to their profession, and who understand it so deep that they really can help a lot of budding professionals, students, or anyone who is interested in the topic to understand it with nuances, with depth, that will only help to excel in profession. Now, today, I have someone who I regard very deeply for his vision and for his very deep and granular view about the things. I have had the opportunity of working with him, and I have seen how he looks at things very differently and gives completely new perspective. So I'm talking about PVG Menon, who we'll talk about more about his introduction in due course, but who is really an authority on electronics and semiconductors in India. Good evening, PVG. It's really pleasure having you.
Hi, Faisal. Thank you so much for calling me on to such a well-regarded show.
Thank you. So, PVG, as we have discussed, this show is all about helping, or I'd say passing on the knowledge, the ocean of knowledge which tech thinkers like you have, as well as experience, to the youngsters so that they can understand and know their topics with some depth and with a long term vision, which can help them maybe have a better sense of their profession, of their career, and of the areas that interest them. Now, my first question to you would be that we have seen a lot of transformation in electronics world, especially in recent times. I think smartphone has been one of such devices which has brought in a lot of changes throughout the value chain. Obviously, it has impacted semiconductors as well as other ingredients of electronics, if I say so. So how do you see this evolution of the industry?
Okay, Faisal, this industry typifies what is captured in the very evocative phase. Change is the only constant. In the roughly 3.5 decades that I have spent in this industry, the one thing that has always happened is that every year is new. Sometimes every 6 months is new. Uh, Things have changed, and the pace of change has been accelerating. And if you'll permit me to set it in a little bit of context, I'll come to the change part. But uh, when again, I have a disability that I end up talking to people from the industry all the time. But in one of my previous stints, when I was heading a skill development body, I ended up talking to a whole cross section of people who did not necessarily come from the electronics industry, but needed to learn about electronics for doing their work. And honestly speaking, two words come to my mind when I think about electronics. One is pervasive, and the other is ubiquitous. So let me try and set it in context for you. Uh, Literally, electronics is everywhere. We look at rattles, toy rattles that we give to babies to amuse them or distract them, and you've got a chip in there. It makes, sings a nursery rhyme, and you've got a considerable amount of electronics in high-end medical equipment which is inside an ICU and is helping to save a patient's life, right? You've got electronics in sophisticated industrial applications. You've got electronics in a vacuum cleaner, and vacuum cleaner sales, you've been in the market research industry, they skyrocketed during the pandemic, right? A whole bunch of stuff. You've got electronics and things that people don't even think about. For example, ceiling fans, right? People take a ceiling fan for granted. And if you look at it, a normal Indian household, I mean, now North India is in winter, but in summer, take an average of 3 or 4 fans in a house. They work for 14 to 16 hours a day, maybe even more, and multiplied by the number of houses. And one little electronic circuit with a chip inside can cut that power by half, what is called the VDLC circuit. Now, if you multiply by the size of India, the number of fans that we have, if you cut the power consumption by, say, 40% or 50%,
Hmm.
let me set this in context so everyone understands the role of electronics. You can eliminate a couple of generating stations, right?
Absolutely.
That
Yeah.
is the kind of impact we are talking about. So let me put it this way, Faisal, from a market research perspective, from a policy making perspective, we look at electronics as a vertical, and we say the Indian electronic system design manufacturing segment is $180 billion, products are $100 billion, etc., etc. I don't want to get into too many numbers. That takes away from the point I'm trying to make. But I would submit to you that electronics is a horizontal. It permeates every aspect of our activity. Um, just like software and telecommunications, we take those as infrastructure now, right? And the fun fact is, you can't do software or telecom without electronics. So, just to set this in context, permit me to put a couple of numbers. The electronics industry is about 3.5 to 4% of GDP. But my
Hmm.
contention is it enables another 4 to 5% of GDP. And that is how pervasive and ubiquitous electronics has become, right? And you talked about um, how consumer electronics is sort of booming, how it is driven by electronics. We talked about it. And if I think a little more about what you asked me, there are implications for both the electronics industry and the semiconductor industry. Uh, let's step away from electronics for a moment. Let's look at, say, FMCG, right?
Hmm.
There is customers want newness. So you will see a packaging change. You will see maybe a different flavor coming out if you take something like cookies or something. There are multiple flavors and things like that. Now, if you add electronics to consumer and you track that segment, you're a master of the smartphone industry. Every 4 to 6 months, there is a new product coming out.
Hmm.
And it could be a new feature, it could be a new connectivity, it could be new apps, whatever. But if you look at it from what I like to call a signal chain perspective, which is all the elements, hardware, software, interfaces, all of that, think of the pressure it puts back on the industry and how that pressure grows. So if you look at the semiconductor industry from, say, 15, 20 years ago, We defined a product roadmap. We came up with what we call a reference design.
Mm-hmm.
And we said it's good for the next 3, 4, or 5 years, by which time the next chip would come out.
Okay.
Today, we have to have at a minimum 3 or 4 variants of a chip.
Mm-hmm.
One has Bluetooth, one has Wi Fi, one has something else. And our reference designs, if you look at areas like, for example, IoT, consumer electronics, the reference designs have multiple interfaces. Some have graphics accelerators, some have something else. If it's IoT, then you have newer and newer sensors getting added. And then the electronics, the processing engine, the semiconductor component in it, is enabling huge advances with software. So, in a sense, the electronics and the semiconductors are proving to be the tailwind which are driving newer and newer applications. That's
Right.
my view on the whole thing.
Yeah, absolutely. Like, in mobiles, for instance, I remember just a decade back, we would see a particular mobile handset or model selling, say, 5 million units a year in India. Today, even if any model crosses 1 million, that's considered, okay, this model has done nice. That's the pace, and that's the kind of, I think, I would say clutteredness, but I don't know what others have to say. uh, th- so there's also, like, one of the issues, perhaps in semiconductor, or one of the changes that has happened, is also on the type of, chipset or processor. Okay. We are now becoming more, I would say, application specific. Is that the case? And if that is the case, so how does that, impact the entire semiconductor industry? Like,
Okay,
are we heading towards more customization and it becomes
yeah,
more software driven?
yeah. So you have touched upon a major mega trend that is impacting the industry today, right? Again, permit me to take 30 seconds to set context. Earlier,
Sure.
if you were a classical semiconductor company, Intel, AMD, Qualcomm, any of these companies, you would put a chip in the market. You would say it has ABCD functionality, and you would work with product makers. Could be an Apple, could be a Samsung, could be a Cisco, could be any of these guys, right? And you would say that 2 years down the line, I'll give you the next chip that is the specification there, things like that. But what happened is, and all, and from the time I was selling chips, which was 15, 20 years ago, we would sell with what is called a data sheet, and we would sit with the customer, work off a block diagram on a whiteboard, define the next generation chip, which would come after 2 years. The problem is that we talked about the shortening lifespan of products, right? And you talked about 5 million mobile phones becoming 1 million, but you have 1 million each of 15 models as opposed to 5 million into maybe two models, right?
Yeah.
So, what has happened is product makers have realized that consumer choices are changing fast. And the classical semiconductor model of giving you a new chip or a new improved chip every 2 years and possibly a new architecture every 10 years is not good enough for them.
Hmm.
So if I take a name at random, Apple, right? Apple has its roadmap and it has a sense of what consumers want on their devices.
Hmm.
But there are choices that you make as a product company when you are doing your R&D and engineering. You are saying, shall I put one chip? If I want more power, I have to put in two chips. It adds to cost. The and it translates to the printed circuit board becomes bigger. You have service issues, stuff like that. So what a lot of these companies did is they said, hey, let's start looking at, can we design our chips ourselves? And this is what I call a mega trend of what I classify as disaggregation of the semiconductor business model. So if you look at the top product companies, Apple, Samsung, Huawei, Cisco, Tesla, right? Of course, also companies which offer services like a Google or a Amazon. All of them said the classical model is not working out for us. And therefore, they said we are going to set up teams which will do custom chips, application specific integrated circuits or ASICs.
Hmm.
And that has massive implications. It has implications across the value chain from how these chips are designed, how they are verified, how they are fabricated. It has implications across the whole thing. What does it mean for India? It means a tremendous opportunity because any of the names that I took, these are not semiconductor companies. Right? Semiconductor companies invest into design, and I've often said it that if you take the top 100 semiconductor companies,
Mm-hmm.
95% of them have a design footprint in India.
Right.
Either they are present directly or they are present through offshore development centers with any of the services companies, or sometimes it's a combination of both,
Hmm.
right? And they also have multiple ISVs or independent software vendors who are writing software for those chips, and they're all present in India. Now, that's for a classical semiconductor company with a uh, finite roadmap. But if you're a product company, you want to focus on building the next iPhone or the next iPad or the next AirPod or whatever. You have enough challenges from a product engineering standpoint. You don't really want to take your core VLSI team beyond a certain size. And so you look at where can I get expert specialists who can scale up.
Hmm.
And that geography is India. And
Okay.
we have, a history of VLSI design right from, say, 1984 when Texas Instruments set up its design center, even before. I mean, not many people know our semiconductor journey started with a Government of India decision in 1976 to authorize the setting up of what was called the Semiconductor Complex Limited in Chandigarh.
Right.
And that fab became operational in 1984. Of course,
Okay.
we had a catastrophic fire in 1989. It took some time before it came back online. I think it took a good 10, 12 years before it revived. But we have a history of doing work around semiconductor technology. And this new mega trend, in my opinion, has huge implications and huge opportunities for India.
Okay. This was my next question, around in this backdrop, whatever, whether you call it, this kind of more of application specific development of chip, or other kinds of things we are seeing or witnessing in the consumer electronics. And this was exactly my question, that okay, a lot of things are already happening. We are potentially now going to see some activity, some action in semiconductor world in India, which I think has been talked about for a long time now. So you talked about the opportunity that India has. Now, how big can this opportunity really become? And then there is also an issue that, obviously I don't think we can look at the developments in isolation. Now, whatever we are trying to do in India, uh, the other, there is world which is also working and active around the same thing. So it always becomes an issue, and I want to bring in here Mr. Vipin Tyagi's question uh, around the size of the node, of which what should be the choice of the node, from business as well as strategic perspective. Uh, so my question here is, are we? I know it's difficult to say, are we going right, wrong, but my point is, like, we are, the opportunity is probably moving fast to lower nodes, and we are probably talking of very, very mature nodes. So, how do we really catch this? Like, will this always remain there as a gap?
It's a it's a complicated question to answer. So, Faisal, about 6 months back, I published an article in a journal, in an academic journal, and what I said there is that um the semiconductor industry is at the confluence of three raging debates. One is on
Hmm.
geopolitics, one is on debates about sustainability, and one is on debates about how do you allocate resources. Geopolitics is self explanatory.
Hmm.
Right? Sustainability, fabs are extremely resource hungry in terms of natural resources, water, uh, power and water, but there are also a lot of chemicals that are used in the process, and the effluent has to be treated, right? And on resource allocation, remember fabs are uh, very, very capex intensive. They need a humongous amount of money to set up. They also need a humongous amount of money to run.
Right.
And world over, semiconductor fabrication has been looked at by governments as a strategic initiative that they want to pursue. Now, India has made the same decision with the PLI scheme, and I'm not going to get into a discussion on government schemes. But suffice to say that the government has been very aggressive in terms of saying we want to establish semiconductor fabrication capability here. And I think we've seen some big announcements in terms of packaging, which is probably the first step. Fabrication is a lot more complicated, but at
Right.
least in packaging, we've got a mega packaging fab coming up and announcements already done. So I'm going to park the thing about fabrication there by saying there are lots of uh, issues there. It's not something I don't want to come in and give you an answer saying we should pick 14 nanometer or we should pick 7 nanometer or whatever, because there are multiple questions there, which probably if I get into that, you will have to run 3 sessions. This session will go on for 3 hours. So let's not do that. Suffice to say that I think two things need to be looked at when you are going to when any policymaker looks at the decision on which node to pick. One is where is the demand in India and around which node is it clustered? Not just today, because bear in mind it takes anything from 24 to 36 months to set up a fab. Let's assume today is day zero and permissions are given today. It will be anything between 30 and 36 months before the fab starts production.
Hmm.
So if I were to use football terminology, don't play the ball where it is. Play the ball where it is going to be.
Right.
So one, we need to know where is the bulk of our consumption, at which node is it today, and what is the trajectory on those products and the chips on those products. And there are industry bodies which have done studies. I am not privy to them, but there is data that is available. It has to be looked at, and decisions have to be made around that. Second, I have heard commentary that we should build on older nodes. Yes, but if you build a fab, you're not building a fab for beating demand today or for the next 2 years. You're looking at
Hmm.
building a facility and an infrastructure which will meet demand for the next 10 years. And the question you need to ask yourself is, if you're doing an argument's sake, I'm just putting a number here at random, if you're going to decide to build a 180 nanometer fab, you've got to ask yourself, in 10 years, how will you be able to load that fab?
Hmm.
Which brings me to, so everything I talked about in the first is about load, which is what is the demand you can generate, because these fabs need to be filled. You're talking about A standard, a small, mid-size, and CMOS fab will be 40,000 wafer starts a month, and you need to ask yourself, can you at least get 30,000 wafer starts a month? Because otherwise, if you don't load the fab, you're going to start incurring losses.
Hmm.
And the second question you have to ask yourself is around technology, what is loosely called the yield from a fab, which
Hmm.
comprises of two things. One, do we have the expertise to make sure that we are getting yield, which is the number of good chips you can harvest from one die? And the number of good chips you can harvest from one die is not just a function of how good your fab engineers are or how good the tape out and the loading onto the wafer is. It is also a question of how good is your ecosystem,
Hmm.
because a fab is not just lithography and those machines. It is also pure gases, it is HVAC, it is effluent treatment. There's a whole bunch of other things. So I don't want to come back and give you a prescriptive answer on which node to pick. I think one needs to analyze the data, and one needs to analyze the data, as I said, in terms of no, not from a perspective of what is the demand today, but from a perspective of what will be the demand by the time the fab comes up and what is the trajectory on that demand.
Okay. So, okay.
So sorry,
Um,
sorry to give you such a convoluted answer.
no, no, no. I know, like, it's a very complicated thing, and I completely agree. It can't be just solved over just 2 minutes, 5 minutes of discussion. I
And
think it will need.
if I may just be permitted to make a remark here, the number of zeros on those bills make that decision even more complicated.
Absolutely, absolutely. I know, but just wanted to take your perspective here, and I think every learned perspective helps to understand things in a better way. Uh, Now, coming on to the other side, of what you have been doing and what I have seen you doing very closely, which is around public policy and advocacy, and that's where I got some chance of working along with you on some reports. Uh, so just as I said, like the target of our show is also emerging professionals now. So how do you bring in that relevance of public policy or advocacy in a business? Why is it so kind of important to have this?
Okay, so let's take a moment to, since you've mentioned there are a lot of young professionals and perhaps a few students on this, let's understand what is public policy, right? Public policy advocacy, and I looked at a Wikipedia definition, and it says public policy advocacy is an omnibus term that encompasses a wide range of activities, all of which are centered around influencing the development and implementation of policies that govern a country.
Mhm.
That's the definition. Basically, you work with government, you work with policymakers, because they are not the experts. If somebody is making policy, if you are in a business or in corporate, or you could be an individual consultant working in the sector, if somebody is going to develop a set of policies and laws and whatever that are going to impact you, then I think you need to step up and participate in that decision making process by giving informed data and
Okay, I think we lost him. Let's try to wait for a few, some time till he is back. And meanwhile, if you have any questions, I would encourage you to put them across in the comment section, and we will be taking them along uh, till the moment we see him back. And I just those of you who join later or may not be knowing about PVG, as a person and his background. So he spent close to 3 decades in the electronics world and semiconductor world. He, initially worked with organizations like Analog Devices and Philips, where he was in different roles, primarily, into business development. And later on, he, switched to or shifted to public policy and advocacy, was leading ISA, which is now IESA, India Electronics and Semiconductor Association. So he was leading it as the president of the organization, and it was the time when a lot of discussion around Make in India, was happening, and then afterwards he also took up assignment of Electronic Sector Skill Council, where he was the CEO, and after that he is working as an independent advisor and consultant in the domain. In between, he also was involved in setting up a fab in India. We'll try to understand if he can share some bits on that as well. I can see him trying to log in back, so my request would be to kindly bear with us, and he should be back in a moment. My Meanwhile, my other request to you would also be, let me know what other topics or what other things we should be discussing in these Tech Thinker sessions coming forward. And uh, if you want any kind of change in the format or in terms of any other, thing you want,
Yes.
we take that. Yeah, I think we lost you in
Sorry.
the.
Yeah, sorry, Faisal. I think there was a catastrophic electricity failure here.
No, no worries, no worries. So I was just, introducing you. Meanwhile, talking about, your background, where you come from. I think we can continue where we had stopped.
Okay, sorry. I was so busy debugging, I sort of lost what
No,
I
no,
was
no.
talking about.
Okay. So, you were talking about public policy, why it's important for businesses, and that's where we kind of got disconnected.
Right. So I think, I gave you I think you got the definition of public policy, right?
Right, right.
And, as a business, as I was saying, I think when I dropped off, that you cannot expect that government knows all the nuances of your business or your sector. And that is
Hmm,
why there are lots of industry associations which represent the voice of that sector of the industry, and they sort of, um, if I may be permitted to use a little bit of hyperbole, act as a friend, philosopher, and guide to
hmm,
policymakers.
hmm,
So if you look at it, there is, in terms of a logical sequencing, there is first, before you formulate a law or a policy, there is first a clear identification and specification of what the need is.
hmm,
Then comes the formulation of the elements that go into it. So this includes what is needed to be done, what will be the consequences of not doing it, who are the intended group of people who have the need, defining the exact elements of what needs to be done, defining the mechanisms by which the law will be implemented. For example, do you need a new department, or can an existing structure, handle it? So Those are some of the issues that go into formulating public policy. And the way that you would deal with this is that, as I said, there are industry bodies, there are national bodies, there's a CII, there's a FICCI, there's a ASSOCHAM, and they operate across all sectors of the economy. Now, if you look at the electronics and semiconductor industry, there are a couple of bodies. There is my, if you will, my alma mater, the India Electronics and Semiconductor Association. There is the Electronics Industry Association, or ELSINA. The smartphone industry has the Indian Cellular and Electronics Association,
Hmm.
ICA. And there are a bunch of other sectoral associations. And each of them takes their segment. uh, they talk to their members, aggregate what are the needs, and those needs will typically get classified in discussions into what is a must have, what is a good to have, and what is the method in which they can be phased in. um, a lot of the issues that industry faces can be broken up into two aspects. One is under the omnibus category of ease of doing business,
Hmm.
tariffs, permissions. If you have to build a factory, then how many permissions do you need, etc., etc., etc. There are issues related to labor conditions. There are issues related to trade practices, fiscal policies, and so on and so forth. There are also geopolitical issues,
Hmm.
and some of it could be protectionism by other countries in terms of not giving access to their markets to products that are manufactured in India. It could be that there are certain countries which are looking at dumping stuff into India to favor their industry and subsidizing them. And how do you protect Indian industry? There are also international agreements that India has signed which have to be honored, and they have implications on how Indian industry will react. And keeping all that in mind, this is how industry bodies sort of come together and build a case and work closely with government. In the um, 12, 13 odd years that I've been involved in public policy, I have seen the government of India to be fairly aggressively active, if I can use the term. And this is across administrations. We've seen a lot of consultation happening with government. And remember, when we are talking about electronics as opposed to design, if you're talking about the manufacturing aspect,
Hmm.
manufacturing does not happen in Lutyens, Delhi. The manufacturing, the factories come up in states. And
Right.
part of the advocacy is also working closely with the state governments,
Hmm.
because there is a policy that the central government makes, the national policy on electronics, for example.
Hmm.
But the employment creation, the infrastructure requirement, all of that is in states where these factories are going to come up. And it is
Right.
not just infrastructure and things like land. It is also access to people. What kind of the electronics manufacturing industry, for example, has always asked for women to be permitted to work in the third shift,
Hmm.
and state labor laws do not in many states permit that. So then you work, this is part of the public policy advocacy, that you work with the state governments, you lay out the economic benefits, you lay out DEI issues, because this, especially the contract manufacturing industry, is very DEI friendly. And keeping all that in mind, you build a case.
Right.
And states also recognize that the electronics industry, particularly the electronics manufacturing industry, is a huge generator of employment. And so their people get jobs, and there is economic prosperity, and therefore you build that case. And there are associated issues, right? There is skill development on a massive scale that is required, and skill development, for manufacturing job roles is very different from skill development for, say, R&D. So again, I'm mindful of time and the vagaries of internet connections. I don't want to go too much. Each of those becomes a topic by itself.
Yes, yes, yes. So, I had a question. Like, you had coined this slogan of innovation-led design and design-led, uh, you know, manufacturing.
Manufacturing.
Yeah, yeah. So, I think, it's still relevant. It's not, it was not just a very time-specific slogan. It's still relevant. Uh, what do you see? Have we really done in this on this side? Where are we really today? And do you think, somewhere I believe that our associations and trade bodies do a more of advocacy than probably there's a need to, probably get more action oriented. That's my personal view, because I don't see us getting into development of standards. I don't see us getting developed, into those kind of areas as trade bodies, and probably that is an opportunity to create very, I would say, very, tech driven uh, barriers, rather than certain barriers which are very, like, at times rule driven or policy driven, which can be overcome in a very short period.
Okay, I would hesitate to use the word barriers
Okay.
because remember that all of us are part of a global um, supply chain, or what is often referred to as a global value chain.
Hmm.
Second, this industry is hugely international. I mean, our VLSI design industry, which is my numbers could be dated, but when I last looked, it was about $35 billion.
Hmm.
Most of it is export. So if you set up barriers, then it is logical to assume that the other guy would also set up barriers.
Hmm.
Having said that, as a country, you need to make sure that your domestic industry is protected if somebody is trying to do dumping,
Hmm.
right? Let's come back to this. So I don't think you can do what is called a country specific standard. Many people in the audience will not even remember this, but in the old days, there was, when video was coming up, there was a Chinese standard called VCD,
Hmm.
and they did something called Super VCD. VCD was the thing and the global standard, and they did a little tweak and called it SVCD. And there was a company called C Cube which made chips only for China. Now the China demand was large enough to justify. So instead of using the word an India specific standard, I would suggest an alternative, which is an India appropriate standard, which means
Okay.
that you use all the parts of the technical standard, but where there are implications for which impact you as a country. For example, if you have a standard which says, it starts with something and then goes on and proposes robotization and automation. Now, we tend to use manufacturing as an engine to drive employment in a
Right.
country like ours. So if you have a standard which specifies robotization, then you need to say that as a country, I will take the good parts of the standard, which is the
Hmm.
technology elements, but the implementation I would look at slightly differently. And that doesn't affect the technology standards, which uh, please follow me very carefully on what I'm going to say. You want to
Hmm.
ensure that the products that come out of this manufacturing process are interoperable with any other product in the world, which is the
Right.
only way you can be part of the global supply chain.
Hmm.
And why am I obsessed with global supply chains? Because manufacturing is not about innovation. Manufacturing is about scalability,
Hmm.
defect free repeatability. The innovation is in the processes and products that result from the manufacturing process, and there are innovations that go into the process to make the manufacturing better and more defect proven. But if every output of that line is going to be different from each other, then that's not manufacturing, that's a custom job.
Hmm.
And manufacturing is all about scale. Product 1 and product 1 million should be exactly the same. And
Sure.
they should be capable of interoperating with any product of a similar nature or upstream or downstream anywhere in the world, and they should be
Hmm.
capable of being shipped to anywhere in the world. Which is
Absolutely.
why, Faisal, 3 years ago, I sort of, if you will, I have a version 2 of my slogan.
Oh.
So, so from innovation led design, design led manufacturing, which was, uh, if I may say, a motherhood statement, a wish list. I
Hmm.
said we should have products that are conceived in India,
Okay.
designed in India, made in India,
Okay.
but which are sold and used all over the world.
Oh. Okay.
And I am obsessed with products because products, you see, are manifestations of innovation realized in a usable form, which is repeatable.
Hmm.
And I would like to see these products not as white labeled, but as brands from India.
Wow.
What I like to call as made in India with pride,
Made
but
in
for the
India.
world, but
But
for the world.
okay. So, I also say that we have a like probably a desire that okay, in these 10 years or so, we have seen a lot of make in India labels on the products. Now it's time that we should see a lot of make in India probably engraved on many components on a PCB. So hopefully that should be the desire for next decade we should have.
So if you look at the commentary, the first batch of capacity um, addition and increases happened because of the PLI scheme in terms of contract manufacturing.
Hmm.
But now, if you look at a lot of the announcements that have happened under what is called the spec scheme,
Hmm.
the special, the scheme for promotion of electronic components, I think it was called.
Right.
And I saw a media statement by the Secretary, Ministry of Electronics and IT recently that the government is actively considering a second spec scheme. Um, there is, um, capacity coming online in terms of components. Is it enough? No. For the kind of market that we are, we could do a lot more. But for instance, uh, I read somewhere that almost all the cell phone chargers that are sold in the country today are manufactured domestically,
Hmm.
right? And there's a significant domestic value addition component in that. If you look at
Hmm.
specific categories, for instance, power conditioning equipment, UPS inverters, which we sell a lot in this country, they are all made locally.
Right.
Now, bear in mind, again, it goes back to what I said about the international nature of this industry. Not everything is made here. The chips we don't make, displays we don't make as yet. There have
Hmm.
been announcements we have seen from an American display company tying up with an Indian display company. They've announced a location as well for their factory. So maybe in the next couple of years, we'll see that happening. Um, I would say that the next big thing for India would be printed circuit boards if we can build on scale here, because that's 10% of the BOM or
Hmm.
8% of the BOM,
Hmm.
right? But unless we can do something about display, compute, and memory, we are not being able to address about 50 to 55% of the BOM, the bill of material.
Right.
But that doesn't mean that we give up the remaining 50%. I mean, we should still
Hmm.
fight for it. But Faisal, again, it comes back to this. If we can define products which are, as I said, conceived, designed, made in India, um, we will have a lot more control as a country on, if you'll permit me a slightly hyperbolic reference, on our own silicon destiny.
Okay.
And what I mean to say is In the earlier in the program, I talked about the disaggregation of the semiconductor value chain. Now, it's going to be very hard to take any of those global brands and sell them a chip which is made in India and is going to be fabricated in India, et cetera, et cetera. Because those are decisions which are made at global headquarters looking at a variety of factors. But if you
Hmm.
have a product that is being designed, conceived, made in India, you can nudge them to use it. I don't want to, for even a second, I don't want to disadvantage an Indian product company.
Hmm. Hmm.
But you can nudge them to use more domestic products and more domestic IPR by um, giving them, let's say, a fiscal package. Let me give you an example. If you're building a very expensive telecom product
Hmm.
and you say that I will come up with a fiscal incentivization program which rewards both the developer of that product as well as the buyer of that product, which is typically a telco, right? And there has to be, you have to work very closely with industry to formulate those programs.
Hmm.
That is when you're going to see true make in India happen. Otherwise, we are going to see largely assembled in India with a little bit of make in India.
Hmm.
But if you want to do true make in India, you need to get creative and aggressive. Let me leave it
Hmm.
at that.
Okay. We have a question again from Mr. Tyagi. What are the implications of OEM making their own semi or IPR? I think we discussed this, but if you would
Yeah,
add.
so if you take any of these custom ASICs, there is, my friends from the semiconductor industry are going to kill me for this, but the semiconductor products of today are the ultimate examples of system engineering at a nanoscale.
Hmm.
System integration at a nanoscale, right? You get a core if you're doing a x86 processor, then you get a core from, whichever. Or if you're doing a RISC processor, you can look at ARM, you can look at RISC-V. There are options. You get your memory from, DDR4, DDR5 from Rambus or someone else. You get your specialist connectivity. There are vendors who will give you Bluetooth or USB or Wi-Fi or whatever.
Hmm.
The radios come from uh, Broadcom, Qualcomm, etc., etc. And you integrate the whole thing together. Now, the secret sauce is if they decide to build specific add-ons. It could be, let's say, they have incubated a GPU company,
Hmm.
not the one starting with N, right? I mean, I personally know of a few startups who are under the DLI scheme who are building stuff which the preliminary simulation numbers are very exciting. Let me just leave it at that. I don't want to
Okay.
speak for them; they should speak for themselves. But if that is integrated, that is the secret sauce, and that IPR remains with them. But otherwise, you are doing licensing deals for all your custom silicon,
Hmm.
and per chip, whatever is the licensing deal, whether it's a per chip royalty, whether it's a one-time license fee that you pay upfront, or a combination, those are there. But typically, if you're going to do an ASIC, you wouldn't get into doing an ASIC unless you want to customize it. And customization inevitably means there is IPR involved. Either it is developed by you or it is contracted and you take it from someone who's done it specifically for you.
Hmm.
That's how it is.
Okay.
And by the way, that silicon is not generally available. You can't go to a large distributor like an Arrow, an Avnet, and give a part number and say, I want this. I mean, the A5 or A7 chip is only going to be available to Apple. You can see it on an
Hmm.
iPhone or a Mac or whatever, but you're not going to get it on a Samsung phone.
Okay. Okay. So I had, a third thing in mind, and I want you to briefly touch upon that. You have also done a business development of these advanced high-tech uh, electronic components. Uh, did you like witness any kind of differentiating factor over there than probably business development of other electronics?
It's a fascinating question. And let me put a caveat. I come from a different era when, today things are very different. I'm not in direct frontline selling, but I come from an era where we sat down in a conference room with the customer and we all worked off a block diagram and we had data sheets, which
Okay.
became CD-ROMs, right? So you, I would only say this, and that comes from my experience. A good semiconductor sales per professional does not only know his products, he knows what the competition is offering, he knows what is the business of his customer, and if the customer is an intermediary, if you are a chip company selling to, say, a tier one automotive supplier, right, which is making instrument cluster or something like that, then you got to know what is the business of his customer as well.
Mhm.
And I often, my boss in one of the companies I worked for said, a good semiconductor salesperson not only has the ability to look ahead, he also has an ability to keep one eye at the back.
Okay.
And the back is basically referring to what is your competition doing,
Okay.
right? And it's many years have passed, so it's okay. I'm not breaking any official secrets act. I can share a event from 35 years ago when we were at a trade show in the US and a company comes up and says, would you guys want to do an MP3 decoder?
Okay.
And we looked at it, and this was the time of Windows 3, 3.1, I think. And there was one company called Napster, which was constantly in legal trouble. And we
Okay.
looked around. This was college kids ripping off, songs from cassette players in those
Hmm.
days. And we said, nah, we'll pass. And I know for a fact that two of my competitors also said, nah, we'll pass.
Oh.
1.5 years later, we were scrambling to have an MP3 decoder. So you need to have a 360-degree view, right? You need to know what is your competition doing. You need to keep a track of what are trends. So, Faisal, in those days, we didn't have like we have today. We didn't have large format stores like a Chroma or a Reliance Digital kind of thing. So every time I went to the US, for example, I would make sure that every evening I went into the large electronic shops like a Good Guys or a Radio Shack just to
Hmm.
see how do consumers react, what do they buy on. And I would like a ghost prowl the aisles of those shops, looking at trying to understand what is it, how does a salesman on a commission sell something.
Hmm.
There are many stories I can share, but not today. We are out of time. So,
Yeah.
but
Well.
all I'm saying is a good semiconductor salesperson not knows not just what he is doing or his competitors is doing. He knows what are the pain points of his customers, and he also knows the customer's roadmap as much
Hmm.
as possible,
Absolutely.
and preferably the customer's competitors as well.
Wow. So I don't know. Is it 360 or 720-degree, whatever? Way.
No, but be a sponge and soak in information.
Hmm.
And as I often say, the best quantum computer in the world is between your two ears.
I think these days probably it's again, no offenses. I think a lot of business development people believe in following their clients on Instagram and talking about the holidays they were enjoying and all that, and that's how they probably show that okay, they are very personalized. But
And
anyways,
sorry if I can add a sarcastic comment. Chat
yeah.
GPT is not going to give you 360-degree vision.
Okay, that's true. That's true. Okay, to end this show, I also wanted to understand if you're not thinking electronics, what are you doing?
Macroeconomics. I'm a very
Okay.
boring person. Economics fascinates me, and
Okay.
and I have a few friends who are not in the electronics industry. They're academicians, very close friends from many, from my bachelor days. And every time we meet, inevitably the talk goes to macroeconomics and uh, public policy, not including electronics.
Wow. So this brings me to one interesting thing. I was just attending one of the keynotes of Intel just a few days back when they kind of announced a lot of AI enablement. So they used a very the incumbent Intel CEO. He used a very interesting phrase, siliconomy. So that is what interests you, silicon and economy.
No, and also the what is happening in the knowledge economy fascinates me, and I think you're going to see technology is pervasive everywhere, right? And you're going to see more and more very innovative uses of technology to, for example, alleviating climate change. You remember after the tsunami, there was a massive innovation outsurge on how do you predict natural disasters before they happen. There are startups in India. I don't want to again take specific names, but there are startups which are looking at doing very, very interesting things around technology. It's nothing to do with electronics. It's about, a lot of work happening on algorithms to forecast a natural disaster at least 4 to 6 hours before it happens so
Hmm.
that you can save lives. So there's lots and lots of things happening, and technology is enabling, um, to use an overused phrase, quantum leaps in how we respond.
Hmm. I think a very apt reference and
And one lifetime ain't enough to know all about it.
okay, but maybe I think with these tools, you are able to multiply yourself. Of course, not intelligence, but maybe assistance. You are able to multiply that and make best of the time. Uh, uh, I think it was really an interesting discussion and insightful as much as I had expected because it has always been really, there has always been something new, something interesting, something uh, a different perspective to look at for me as personally when I talk to you whenever we get a chance to interact, and I'm sure today taking it to audiences, uh, they would have also liked the conversation and understood things in a, I would say, deeper perspective. I really thank you for your time and your insights, your references, uh, maybe some secrets you shared. For all that, I really thank you and thanks for spending time this evening with us.
Thank you, Faisal. And on a lighter note, the internet outage in between reminded us that Mr. Murphy is never far away from any of these meetings.
Oh, that's yes, that's true. That's true.
Thank you so much to both
Oh,
both to you, Faisal, for giving me this chance, and to the audience.
yeah. Thank you. Thanks, audience, as well. Have a great day. Bye.